and click the bell icon for the latest update. Today we're gonna start with your class of chemistry here. That has been chemistry for class 11. That is part 2. The class for part 2 is 6, and before that we had done your unit 1, which is being 1 to 7 we had done, and in part 2 we have started with unit redox reaction. That has been the 8th unit. Now we'll just start discussing about the balancing of redox reaction. Balancing of redox reaction. So in balancing of redox reaction, the two methods are used to balance the chemical equation for redox processes. One of these methods is based on the change in the oxidation number of reducing agent and the oxidizing agent, and the other method is based on splitting the redox reaction into the two half reaction, one involving the oxidation and the other involving reduction. Both these methods are in the use, and the choice of their use that rest with individual using them. So now we talk about here is for oxidation number method. That has been the first one. An oxidation number method. In writing equation for oxidation reduction reaction, just as for the other reaction, the compositions are the same way that the reaction, the compound in the formula must be known, and for the substance that react for the products that are formed. The oxidation number method is now best illustrated in the following steps. So we have different steps here. That has been the step 1, which is write the correct formula for each reactant and product. Write the correct formula. For each reactant and product. Now for the step 2. Identify the atoms which are undergo change in oxidation number in the reaction by assigning the oxidation number to all the elements in the reaction. Which undergo change in oxidation number. In the reaction by assigning the Now for step 3, calculate the increase or decrease in the oxidation number per atom and for the entire molecule ion in which it occurs, and if these are not equal, then multiply by suitable coefficients so that these become equal. And if you realize that two substances are reduced and nothing is oxidized or vice versa, something is wrong. Either the formula or the reactant or the product that are wrong and oxidation number that have not been assigned properly. So that these become equal. If you realize that two substances are reduced and nothing can be oxidized, as I told you, that or oxidized or vice versa, something is wrong. Either the formula of the reactant and the product are wrong or the oxidation number that have not been assigned properly. Okay, now we have go for the step 4. And that is ascertain the involvement of ions if the reaction is taking place in water. step 5. Make the numbers of hydrogen atom in the expression on the two sides that is equal by adding water H2O molecule to the reactant or the product. Now also check the numbers of oxygen atoms. If there are the same numbers of oxygen atom, let us now explain the steps that is involved with the help of a few problems that has been given, and we had discussed step 1, step 2, step 3 and step 4 and step 5 of course. So we go for it and we'll discuss one of the questions related to it, and that is here we go. So there is a question related to it. We'll discuss the 8th and the 9th question here itself. So to go for the same. So the question we have: write the next ionic equation for the reaction of potassium dichromate 4, that is C2Cr2O7, with sodium sulfide and Na2SO3 in an acid solution to give a chromium third ion and sulfate ion as well. So we go ahead. let's go for the solution for step 1 here. The skeletal ionic equation which is Cr2O7 aqueous plus SO3 aqueous, that will give Cr3 plus aqueous plus SO4 aqueous. Now we talk about for the step 2. You have to arrange or assign oxidation number for Cr and Cs. Cr and S. Cr2O7 aqueous plus SO3 aqueous gives Cr aqueous plus SO4 aqueous plus 6 minus 2 plus 4 minus 2 plus 3 plus 6 minus 2. This indicates that the dichromate chromate ion is the oxidant and the sulfite ion is the reductant. So we talk about step 3. Calculate the increase and decrease of the oxidation number and make them equal. Cr2O7 aqueous plus 6 minus 2 plus 3SO3 plus 4 minus 2. This is in aqueous. Then give 2 Cr3 plus 3 aqueous plus 2SO4 aqueous plus 6 minus 2. Now we go for step 4. As the reaction occurs in the acidic medium and further the ionic charges are not equal on the both sides, and 8H plus that on the left to make the ionic charges equal, it will be Cr2O7 aqueous plus 3SO3 aqueous plus 8H plus, that will give 2 Cr3 plus aqueous plus 3SO4 aqueous. Now we go for it, the next one, which is step 5. That finally count the hydrogen atom and add approximate that is approximate numbers to the water molecule, that is 4H2, and write to the receive the balanced redox reaction. So we go for it here, which is Cr2O7 aqueous plus 3SO3 aqueous plus 8H plus aqueous will give you 2 Cr3 plus aqueous plus 3SO4 aqueous and plus 4H2O liquid. So for another we talk about here, that has been another question, we solve it, and of course that has been important one. So we go for here. The question we have is and that is your for the permanganate ion reacts in the bromide here, and ions in the base basic medium to give a magnesium or dioxide and bromine ion. Write the balanced ionic equation of the reaction here, so we'll go for it. Permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ions. Write the balance ionic equation for the reaction. So here we go. Solution. Step 1. We have to the skeletal ionic equation we have to find out. So we go for it. MnO4 minus aqueous plus Br minus aqueous will give MnO2 solid plus BrO3 minus aqueous. The step 2 we have assign oxidation number for Mn and Br. Plus 7 aqueous plus Br minus 1 aqueous MnO2 plus 4 plus BrO3 minus plus 5 aqueous. This indicates the permanganate ion in the oxidant and bromide ion in the reductant. So now talking about step 3rd. Calculate the increase and decrease of the oxidation number and make increase equals to the decrease, and then step 4 we have. So first we do step 3. 2 MnO4 minus, that is plus 7 aqueous plus Br minus 1 aqueous will give 2 MnO2 plus 4 plus BrO3 plus step 4. As the reaction occurs in the basic medium and the ionic charges are not equal to on the both sides, and add 2 OH ions on the right to make the ionic charges equal. So we go 2 MnO4 minus aqueous plus Br minus aqueous will give 2 MnO2 solid plus BrO3 minus aqueous plus 2OH minus aqueous. Talking about the step 5. Finally, count the hydrogen atom and add appropriate number of water molecules, that is 1 H2O molecules on the left side to achieve balanced redox chain, which is 2 MnO4 minus aqueous plus Br minus aqueous plus H2O liquid 2MnO2 solid plus BrO3 minus aqueous plus 2OH minus aqueous that we have, and we're gonna end up with this. Now we discuss the half reaction method in the next coming class, that is of class 7 for that is of chemistry. In terms of it, physics part 1 we had started with, and we had completed physical world and units and measurement we are in. In terms of we are dealing with quantitative aptitude, which we had started with arithmetical ability, and that we are in 13 topic. Coming towards CBNST, that is computer based numerical and statistical technique, we are dealing with this AR diagram we are dealing with. In terms of chemistry, what I said as your part 1 we had completed, as I told you for class 11. Here we had completed some basic concepts of chemistry, structures of atom, classification of elements and periodicity and properties, chemical bonded and molecular structures, states of matter, thermodynamics, equilibrium, appendix. That what we had discussed. In terms of part 2, that we had started with the unit 8, which is redox reaction, which is classification ideas of redox reaction, oxidation and reduction reaction. Redox reaction in terms of electron transfer reaction, oxidation number, redox reaction and electrode processes. Unit 9 is your hydrogen. Unit 10 is your S block element. The unit 11 is the P block element. 12 is organic chemistry, some basic principles and technique. Unit 13 is hydrocarbons. Unit 14 is environmental chemistry. So here we're gonna end up with, and thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.